So let's assume, right, we are calculating our final grade, okay? So you are writing the code, okay? So you're trying to do data analytics, right? You want to do, for example, clustering or classification. All algorithms are already there. You will learn these kind of things, okay? There are a lot of packages on the internet. You download and use it. So it is almost impossible for you to read the details in the package, because if you are not a researcher or PhD in machine learning or data mining, you don't need to do that, okay? So what you need to do is to understand how to use the package. For example, how I can use inputs, load my data set, right, in the package and use it. That is your main focus, right? So in this case, you will read help document for each package. You will see that in the help document, it will explain to you how to load your inputs, how to load your data in the method and use it. And you are interested in what? In the output. You are not interested in what? In the details in the package. Because unless you are a researcher, you want to either revise the algorithm or invent new algorithms, which are not interest of most, for example, master students. Because as a master students or even a PhD not in data mining machine learning, you want to use it, right? Then your focus is to learn the input and output. Okay, you will skip the details in the package. In this case, right? So the package has to be written in a good way. In this chapter, we will learn this concept, which is method. Okay, method. A method is a package. Okay, so all the detailed algorithms, all the detailed calculations are packaged, right, inside this method. Okay, so when we write this method in the future, when we want to run the statements or execute the statements inside the package, we just call the name of the package. Calculate final grade, for example, okay, and use it. We are interested in how to load our input and how to use the output. That's it, okay? So what you need to understand is, so it is good to use this kind of methods or package idea when you build your code. Why? Because otherwise, if you don't have these small packages, right, you have to write everything in a very big section, right? It means if you have a small error, it does not work. If you have a small error, you have to debug from the beginning to the end to find where it is, right? And how to fix it. But with this kind of package idea, you can make sure that when I build this small package, it is fully correct. Then move on to next package, it is correct. Then move on, right? With this kind of idea, it is much easier for you to work on big project. Otherwise, you will try to write everything in a very big program, which is a very bad idea, okay? Which is a very bad idea. So this is the idea for methods, okay, for methods. So methods can be used to break complex program into small, manageable pieces, okay? That is the key idea. With the idea of methods, we do not need to write a very big program, which includes everything. Instead, we can break down, right, the big project into small pieces. Then we try to work on each individual piece and make sure that that piece itself is fully correct. Okay? When we are sure that this part is fully correct, we can move on to the next piece. So this approach is known as divide and conquer, or divide and conquer. So that is a very, very useful idea in computer programming, okay? So based on your personal experience in the previous 8 weeks, you may feel this concept is not that important. Why? Because I can see that I create an event handler by double clicking, right? Some control button, for example. Then I put some code inside. It works, I'm happy, okay? It is because the projects we have worked on are simple, okay? It is because this is a first coding class for most of you, for some of you at least, right? So we try to keep things simple. You see that the coding part is only part of the course. Another 50% of this course is to design graphical interface, right? We put buttons, we put labels, we put text boxes, right? We put those things on the form. That is 50%. Another 50% is write some code, right? Why? Because if we are learning a just computer science programming class, we will not deal with graphical interface, okay? We will go to algorithm, data structure directly. You will see there is no graphical interface. Everything is a black screen, okay? Because we are interested in algorithm coding itself. But because we are in business school, and for most of you, you are new in computer programming, that's why we want to balance the coding part. Coding part, 50%. Designing graphical interface, right? 50%. Try to balance. When you see some graphical interface, right? It's easier for students to have interests, right? Otherwise, you will feel the course is dry and it's more challenging. Okay, that is why you see that we focus on graphical interface. Okay, but it doesn't mean actual coding in practice is that simple. It is difficult. Sometimes you need to write thousands lines of statements. You need to spend 6 months, 1 year on a big project, right? In these cases, divide and conquer is necessary. You need to use this strategy, okay? You have to use this strategy. So in general, breaking down a program to smaller units of code, such as methods, is known as modularization. Okay, modularization. For example, right? I have a project. In the project, I need to use what? I need to use a method which can find the maximum number between two numbers. The maximum between two numbers, okay? Use it for multiple times. So in this case, I can either write same code each time when I want to use find a maximum, or I build a package which is method which can use inputs and output the maximum. Okay, so in this case, you see that finding the maximum is part of the project. I want to build a modular, right? I want to build a package for that objective. So that is the idea, how we broke down a program to smaller units, okay, smaller units. So we have two types of methods. The first one, it is avoid method. Avoid method simply executes a group of statements that perform a task and then terminates. It means we do something. We don't have output. That is void. Void means there is no output. We just perform some tasks. That's it. For example, right? One in this course, in all labs and the projects, okay, especially in the second half of the semester, a method which you need for every project is clear button, reset button. What is that? For example, I have text boxes, I have output labels, I have radio button, I have check boxes, right? I have all these kind of things on the form, okay? So when the user use it, so for one time, right? And he or she want to use it for another time, the first step is to reset, clear all the form, right? Input area, clear all output area, reset the choice of radio buttons and checkboxes to the default status. For example, for radio buttons, so reset it to the first option, right? For checkboxes, uncheck all the options, right? Reset the form to the very beginning. In this case, we have a clear button, okay? Clear button. For example, when you need to clear a text box, how to do that? In the midterm, we practice, right? Empty code, right? Empty code. Label button, same thing, set the text property to empty code, right? So for checkboxes, set the checked option for each option to false, right? So for the radio button, put the first option checked status to be true. All the other radio buttons checked property to be false, right? Reset. You can see I have a bunch of statements to reset the form, okay? So in this case, I will put all these statements in my radio button click event handler, because event handler is a special method, okay? It means each time I click my button, that method will be activated. Okay, activated. Let's assume, right? We have another button, which is save the result. So the application requires when the user clicks the save button, so our application will not only save the result to a TXT file, but also reset or clear the form application. So in this case, you see that for the save button click event handler, we still need to use the clear function, right? It means in clear button click event, we need to clear all the areas. Save button click event, right? We still need to clear all the event. We can either copy the same code twice, right? Or declare a method clear, right? Then call this method clear in both event handler, right? You see, in the second way, we can write less amount of code, right? Secondly, when other user read your code, right? It is very clear for them what's going on there, right? It means that this is a much better strategy, okay? Much better strategy. So the second type of method is a value returning method. It will return a value to the program statement that called the method. For example, I want a method which can find the maximum between two numbers, okay? So the input is two numbers, number 1 and number 2. Let me assume X and Y, right? Or A and B, okay? So the output will be maximum between the two numbers, maximum of A and B, right? If A is greater than B, the method will return A. If B is greater than A, so B will be returned, okay? So in this case, we can declare a method max, okay, max, with input two numbers, and it will return the maximum of the two numbers. So in this case, you can see that there is a value returned from the method, okay? So this is a value returning method, okay? We have two different types. The first one is a void method. For example, we have a clear button, clear all the input areas. So in the method, we only do something. There is no value returned, okay? In the second method, we want to find the maximum of the two numbers. In this case, a number will be returned to the main program, okay? In this case, it is a value returning method, okay? Two different methods. So this is one example without methods, without modularization. So we can use one long sequence of statements to perform a task. You see in this case, right? We have my button click method, okay? My button click event handler. So inside this event handler, we have 1, 2, 3, 4, 5, 6. A lot of different statements, right? So when you write, you are the writer of the code. You may understand what's going on, okay? But if I assume I am a programmer, I want to read your code, okay? So if you have so many statements in one event handler, it is hard to read, okay? However, if you break down, right, you break down all these statements into smaller pieces, okay? And you try to use methods to modularize each individual piece, okay? So in this case, you can have less amount of lines, right, in the event handler, because I mentioned when you declare those modularization or the methods, you use meaningful names, okay? With less number of lines, with meaningful names, it is much easier for you and other people to read your code or to manage your code, right? You see, right? The first example is we try to use all the statements in one event handler, but in the second one, we use the idea to modularize the code. We see we in the my button click, we only have two methods. For example, the click is first, read the input. Secondly, calculate result, 2 steps, right? Then for each method, method 2 and method 3, right? So we can have statements to define each method. It means in the my button click, right, there are only 2 lines of statements, okay, which are much easier to read. And for each method, method 2 and method 3, we have their own declaration, okay, in the program, okay. So it is idea to the idea of modularization, okay, modularization. So in the previous labs and assignments, we have used it. Why? Because we use event handler, right? Each event handler is a special of methods, okay? So we have used it, but this is a time that we know that we can build our own method. Okay, we can build our own methods, okay? So why do we need modularization? So let me give you a very simple example, right? Let's assume that we need to calculate the multiplication of matrices A, B, and C, okay? You may forget what is matrices. You can think about it as what? As a worksheet in Excel with rows and columns, okay? Rows and columns, this is a matrix. Why I use a matrix as an example? Because when you do data analytics, most data files are in Excel, CSV file, or Excel file, okay? If you have a data file in Excel, it's matrix, okay? The input is matrix, okay? Matrix. So when you want to multiply the matrices A, B, and C, 3 different matrices. Without modularization, we need complete statements to multiply the 3 matrices, which will be very complicated, okay? If you check your college math book to find how to multiply matrices, which is not that obvious, at least you need to do a lot of simple calculation and sum up, okay? However, if we want to use the idea of modularization, we can do what? We can declare a method to multiply 2 matrices, okay? Let's assume we have downloaded a method which can, from internet, that method can multiply 2 matrices. Let's assume we still are a little bit confused about how to multiply 2 matrices, but we find some code on internet somewhere, okay? It can be used, we find it. The code is to multiply 2 matrices, okay? But our objective is to do what? Is to multiply 3 matrices, which is a little bit different from the code we download from the internet, right? But we can use it to accomplish our objective. How to do that? So it is, we first, right, matmul with matrix multiplication A and B, first two, okay? Then use the result as an input of another call of matmul, matrix multiplication. Then in this case, we use the code we download from internet. First, we multiply the matrices A and B, okay? Then we multiply the result with the C. After this one line of statements, right? We actually multiply the three different matrices without writing any code to multiply, right? Matrix, okay? You see this example, how we download the code from internet. It is like when you learn data mining course in our department. You will see, so the professor will introduce the basic idea of the data mining algorithm, okay? We will not go to technical details. You have the basic idea. And he will tell you, so the possible packages you can use to call the algorithm. So in this case, you know, right, the basic idea of the algorithm, how it works, what's the input, what's the output, right? Then you find the package, or download some code from internet. In this case, right, you do not need to write any code for the algorithm itself, but you can use it by putting input and analyze output, right? You see, this is one example, right? We have not written any code for matrix multiplication, but we can download some code from internet. It's easier, it's everywhere, right? By using the code we download from internet, right? We can multiply the three different matrices, okay? This is one example, okay? So you can also multiply BC first, right? Then multiply A with the result, okay? So this is how we are, this is one simple example of the idea modularization, okay, modularization. So the first method we want to learn is void methods, okay, void methods. A void method simply executes the statements it contains and then terminates. It does not return any value to the code statement that called it. So we do something in the method. When we are done, we're done. There are no return values, okay? So to create a method, we write its definition, okay, definition. So that's why sometimes we define a method, okay, we define a method. So a method definition has two parts. The first part is header. The header is the method header appears at the beginning of a method definition to indicate the access mode, the return type, and method name, okay? We have access mode, return type, and method name. The second one, it is body. So the method body is the collection of statements that are performed when the method is executed. Okay, we have two different parts, header and body. Okay, header and body. So the method header has four different parts. Okay, the first one is access modifier. So it is keywords that defines the access control. You see that we have private and public. So private, it is the method can be called only by code inside the same class as the method. Public is the method can be called by code that is outside the class. It is local or global. Okay, I use other terms, local or global. So when you write a method in your form application, if you choose a keyword private, it means this method can only be used inside this form class, okay? Outside this form class, this method does not exist. It is not there, we cannot use it. However, if we declare a method to be public, it means we can call the method outside the form class, okay? In a different form, we can use it. So it is global. I use term global. So my comment to this thing is, in this course, most of the time we use private. When you want to use public, the term public, be very, very careful. Because in computer programming, global variables, global methods are not recommended. Why? Because in a very complicated project, you have so many things, okay? It means when you have a global variable, so when you unintentionally change its value somewhere, and you did not notice that, then you are in trouble. Because you have so many lines of statements, you have no idea what's going on, messed up, okay? That's why when you want to use global variables, public, be very, very cautious and careful, okay? The next part is return type. So it specifies whether or not the method returns a value. So for the void method, see this example, for the void method, so the return type is void, it means there is no return value, okay, a void. If we have return values, we will use the corresponding type. For example, int. If this term is int, it means this method will return a int value. If you declare the method to be int, however, when you define the method, you forget to return a int value from the method, C# will give you an error. C# will tell you there is no return value from this method. It's an error, okay, it's an error. So this is the second part, return type. The third part is method name, okay, method name of the method. You see in this example, so if you compare the name of this method with the naming convention we have learned before for controls, for variables, right? So one obvious difference is we are not following camel convention. Okay, this is one thing you need to remember. So for controls, text box, labels, buttons. For variables, right, we follow camel convention. What is that? Camel convention means the first word will start with a capital letter, right? Starting from the second word, so the second word and the third word, the fourth word, these words will start with a capital letter. The first word will start with a small letter, that is camel convention, okay? Remember, camel convention is used for what? Controls and variables, okay? However, for method, we do not follow camel convention. The naming convention, it is Pascal case convention, okay? Pascal case. What is that? It is every single word will start with a capital letter, including the first word. You see, in this example, we have two words, right? In the name of the method, display the first word, message the second word, okay? Both words need to start with capital letter, okay? You have to remember this. Why? Because if you don't follow the naming convention in your project, there will be no error. I can tell you there will be no error. However, this is bad programming style, okay? If we don't follow this convention, we are not professional, okay? We want to be professional, so we will follow this naming convention, okay? So for methods, we follow a Pascal case convention, okay? It is all the words will start with a capital letter or capital letter. So the next one is parentheses. So you see in this example, right, there is nothing inside. However, this pair of parentheses has to be there. even though it's empty. In the next section, we will learn how to fill in something there, right? In this case, it is empty. You may ask, can I skip it? I don't want to use it. No, it's error. You have to have a pair of parentheses for method definition, okay? Even though in this case, it is empty. We have to have it, okay? So you see that for this example, okay, we have access modifier private, okay, in the course. So for it's easy for you to, most cases we use private, okay. So the second one, it is return type. We are now learning void type. It is no return value. The third component is method name. In this case, we have display message. Both words has to start with a capital letter. It is Pascal case convention. The last component is a pair of parentheses. Even though it is empty, it has to be there. It has to be there. Then we have a pair of curly braces. Inside this pair of curly braces, we have statements for the method. Okay. In this example, it is very simple. So for this specific method, we will only see a message. This is the display message method. Okay. This only message we are going to see. Okay, we are going to see, which is very simple. So what you need to learn from this slide is so the format of the method, how we declare a method. Okay, declare a method. So declaring methods inside a class. You see, this is a class, right? Methods usually belong to a class. So in our C# projects, methods are created inside the form1 class. Okay, form1 class. So this is if you have an empty form, right? This is the code you will see. So, and after the public form, this part, public forms 1, right? So we can declare our own methods. Okay, we can declare our own methods. So next one is calling a method. A method executes when it is called. Event handlers are called when specific events take place, but methods are executed by method call statements. A method call statement is the name of the method followed by a pair of parentheses. You see, when you call a method, we still need a pair of parentheses, okay? So in this example, the event handler is go button, a button go, right? So inside the method, we have first line is we display a message. This is the go button click method. In the second one, we are calling. We use a term call. Official term is call, okay? We are calling the method display message, okay? You can see that we define the method display message outside the go button click event handler, okay? Then you may have a question, which is, oh, I'm calling display message method in the go button click. Do I need to put the definition of display message before the go button click? For example, you see in this case, right? Display method is below, right? It is below go button click. Remember, we learned statements are executed sequentially, right? Do we need to put it before, or we can put it just after, like this? The answer is yes. We can do this. Why? It is because before we run the application, we actually compile the application in C#. Okay? When C# compiles the application, all the methods will be loaded first. Okay? It means when you run the application, all the methods are already there. Okay? It is not sequentially, it is in the compiling process. When C# compiles the application, all the methods, event handler, self-defined, methods are loaded, okay, in the compiling stage. Okay, that is why you can put the display message below the go button click or before, okay? So for convention, let me tell you, for convention, okay? Usually we put all the self-defined methods in the end of your code. Okay, because why? Because for other code, they have actual functions in your application, right? So they are main. However, when people are interested in the details of your methods, they go to the end to check your definition. Okay, that's why for programming convention, we would like to put self-defined methods in the end of the code. Okay, in the end of the code. Okay, in the end of the code. So this is one example of void method. You see, so we have a method clear form. Okay, still remember, you need a pair of parentheses for the method, both for definition and for calling the method. Okay. So for the clear form method, so we have private access modifier, void no return value, clear form. You see, the name is very clear, right? Let's assume I have no idea what are the statements in this definition. I have not read that definition, okay? But when I read the name, right? It's a meaningful name. I understand. Oh, this method is to clear the form. Okay, that's why usually we use meaningful name. Okay, meaningful name for the methods. So in the definition of the method clear form, you can see we have first name text box dot text empty quote clear, last name text box clear, form mask text box clear, order date mask text box clear, right? Product quantity text box clear, product subtotal label clear, sales text label clear, order total label clear. Then also usually we put the focus, right, to the first input area. Okay, so in the future, this is order button. If I have another button in this event handler, I still need to clear the form first, right? I can still just call the method clear form. Then the form will be cleared. Okay, will be clear. In this method, you can see that I do not have any return value, right? I just clear all the content on the form. That's it. Okay, that's it. So this is one example for void method, okay? So return point, when calling a method, the system needs to know where execution of the program should return to after the method ends. The system saves the memory address of the location called the return point to which it should return after the called method executes. When a method is called, the system jumps to the method and executes the statements in its body. When the method ends, the system jumps back to the return point and resumes program execution. Okay? Actually, when you debug the code, you will see it very clearly because you have an arrow to indicate where it is. So let me explain how it works, okay? Let's assume C# is working on this application. So when you click order button, C# see this going inside this order button click event handler. C# is here, okay? It is here, clear form. When C# finds clear form is a method, C# tries to allocate where is the definition of clear form. Remember, C# is currently here, but it tries to find next level, okay? And C# finds, oh, next level is here, okay? C# remember the current location and move into clear form definition. So C# is now here. So shall finish 1, 2, 3, 4, 5, 6, 7, 8, 9. When C# finishes all the 9 statements, right? Remember, still C# remembers he's here, right? Jump out, go back to here. Continue with other statements, okay? This is how it works, okay? How it works. So top-down design to modularize a program, programmers commonly use a technique known as top-down design. It breaks down an algorithm into methods. Okay, the process is performed in the following manner. The overall task that the program is to perform is broken down into a series of subtasks. Okay, try to break the big project into small objectives. Each subtask is examined to determine whether it can be further broken down into more subtasks. This step is repeated until no more subtasks can be identified. Okay, when you work on big project, this is very, very important, useful. For this course, it's okay because everything is simple. But when you start your new job, you need to build some code. It is very important, very, very important. So once all the subtasks have been identified, they are written in code. Okay, they are written in code. Okay. So the next topic, it is passing arguments to method. What is that? When we call a method, sometimes we need input. Like the example I have used. When we want to find the maximum of the two numbers, right? We need two numbers as input, right? Two numbers as input. So in this case, we use arguments. The term is arguments, okay? Arguments. An argument is a piece of data that is passed into a method when the method is called, okay? For example, the first method we have learned in this course is message box.show, right? In the exam, that is also one of the first coding questions. And I ask you to display your name, right, in a message box, okay? So in the message box.show method, we have a pair of parentheses. Inside this pair of parentheses, we have a string. So now we learned the method. You can see that for the message box.show method, the string, in this case, hello, the string is the input. It is, the term here is, it is the argument. Okay, this is the argument, okay? Another thing is that this display value method passes 5 as the argument display 5. You see, here it is 5, okay? So we can also use a parameter is a variable declared in a method header that receives an argument that is passed into the method. So we learn a very important concept here, okay? What is that? So in this example, right, we private, okay, access modifier, void, no return value, display value, but in this case, inside the pair of parentheses, it is not empty. Inside this pair of parentheses, we have something which is int value. Int is a type, value is the variable. We call it parameter. Okay, it means for display value, that method requires an input. That input is a int number. Okay, that input is an int number, okay? If we go back to here, when we call the method display value, actually, we would like to pass 5 to the method. In C#, it means when C# try to execute all the statements inside the method, C# will plug in 5 here as the value. Plug in 5, right? Plug in 5. When C# go to message box.show value.toString, C# will do 5.string. It is try to transform 5 to string, right? To string. So it is we pass value 5 to the parameter value in the definition of display value or display value. Okay, display value. So this is a very important concept, how the method will work, or the method will work, okay? Method will work. So contents of variables as arguments, okay? You can pass the contents of a variables as arguments. For example, x equals 5, okay? So here, x is a variable, int, right? In the definition of display value, int is a value is a int. We need a int, right? Because x is a int, so x can be used as a parameter argument, right? Similarly, x is a int. X times 4 is also a int, right? So we can pass x times 4 as the parameter, all the arguments, right? All the arguments. So the method call argument is passed to the parameter in the display value method. So in the first example above, x is an int variable with our value 5, and its content are passed as an argument, okay? In the second example, the expression x times 4 produces an int result 20. 5 times 4 is 20, right? Then 20 is a int, so it is passed as an argument, okay? An argument. Another example is I use double quote 700, 700. If I have double quote, right? 700 is a string, not a number. Okay, it is a string, not a number. So the display value requires a int parameter. So in order to use this 700 as an argument, right, we have to use int.parse method. .parse is transform the string, a string to a int number, right? And we can still display the value 700. Okay, 700. So in these two slides, what you need to learn is how, when you call a method, how to transform your input to a method, right? And use it. It is also very useful concept when you learn, for example, you take a data mining course in our department. It requires you to use R, okay, R. There are a lot of packages, data mining algorithm packages in R, okay? Each time when you want to use it, the first step is to read the help document, okay? In the help document, so the document will explain all the input areas in details. Okay, you need to know that if I want to use this data mining algorithm, okay, what kind of arguments I have to pass to the method. Okay, that is so how we pass the arguments, okay, arguments.